everyone. In this video, we are going to learn what is a continuous random variable and how to write the probability distribution function along with its cumulative distribution function, that is p.d.f and c.d.f. Continuous random variable क्या है? It is a special type of a random variable जिसकी values एक given range या फिर interval में होती है. For example, if I say x is a random variable that measure the height and we say height of randomly selected person. अब इस केस में जो random variable है क्या वो continuous है या discrete है? In this case it is a continuous. Why it is a continuous? If I say that कि sample space में हमारे पास student हैं जिनकी height 150 सेंटीमीटर से लेके 190 सेंटीमीटर तक है. अब यहाँ से आपने एक स्टूडेंट को सिलेक्ट किया है. कैन यू से दैट द स्टूडेंट हाइट इज एग्जैक्टली 160 सेंटीमीटर और एग्जैक्टली 161 सेंटीमीटर? पॉसिबिलिटी है. हाइट क्या हो सकती है? 160.5 सेंटीमीटर. इट्स नॉट दैट ना कि 160 सेंटीमीटर के बाद 161 ही आएगा. वी कैन से दैट कि स्टूडेंट की जो हाइट है that definitely is lying between 150 to 190 सेंटीमीटर. तो यहाँ पे हमें रैंडम वेरिएबल की जो वैल्यूज आ रही है that lies between a given range. Exactly नहीं हम काउंट कर सकते. Therefore, this is a continuous random variable example. Let's take one more case. Suppose x denotes the time taken by the computer to complete a task. तो यहाँ पे भी जो टाइम आएगा that is not a fixed value. तो वो टाइम भी एग्जैक्टली 10 सेकेंड होगा या 15 सेकेंड होगा, वी डोंट नो, बट इतनी श्योरिटी है कि 10 to 20 सेकेंड्स के बीच में टास्क कंप्लीट हो जाएगा. सो अगेन वी आर गिविंग द आंसर इन फॉर्म ऑफ अ गिवन रेंज. सो इट मीन्स इट इज ऑल्सो अ कॉन्टिन्यूस रैंडम वेरिएबल. टेकिंग वन मोर केस, अमाउंट ऑफ रेनफॉल इन अ डे. तो कितनी रेनफॉल होती है उसकी अमाउंट प्रेडिक्ट करनी है. Again, we generally say between 2 mm to the 3 mm. We never say exactly 2 mm. So it means this is also an example of a continuous random variable. Now let's learn how to write the probability distribution function in the case of continuous random variable. Let x is a continuous random variable that takes the value from the interval minus infinity to infinity. तो यहाँ पे random variable की values हम generally ले रहे हैं from all real numbers. The function fx of the random variable x is said to be a probability density function if it satisfies these two conditions. The first condition is the probability corresponding to each random value greater than or equal to 0. So fx आपकी एक probability ही define कर रहा है. सबसे पहले कंडीशन क्या है? प्रोबेबिलिटी हमेशा ग्रेटर देन इक्वल टू 0 होनी चाहिए for every value of x in this interval. Second condition, the integration from minus infinity to infinity of the function is equal to 1. Means the total probability है वो 1 होनी चाहिए. यहाँ पे फंक्शन कॉन्टिन्यूस है, डिस्क्रीट नहीं है. डिस्क्रीट में हम समेशन ऑफ द प्रोबेबिलिटीज कंसिडर करते हैं एंड वी से दैट टोटल प्रोबेबिलिटी इज इक्वल टू 1. सेम कंडीशन यहाँ पे भी है, लेकिन हम यहाँ पे समेशन नहीं ले सकते बिकॉज द फंक्शन इज अ कॉन्टिन्यूस. देयरफॉर वी आर टेकिंग अ इंटीग्रेशन हियर. सो इफ वी हैव एनी फंक्शन एंड आई एम टेकिंग द इंटीग्रेशन ऑफ दिस फंक्शन ओवर द इंटरवल, लेट्स सपोज a to b. तो ये हमें क्या दे रहा है? Integration defines the area under this curve. Basically, this gives us the area from minus infinity to infinity that is equal to the 1. It means अगर ये दो conditions हमारी satisfy होती हैं, जो probability हमें f की terms में define की गई है, that is called as a probability density function, or we say p.d.f of the random variable x. Now, based on this, we can also calculate the probability over the interval a to b. मान लो x की वैल्यू माइनस इन्फिनिटी टू इन्फिनिटी की जगह a to b में लाई कर रही है. In that case, how to calculate the probability? That is the integration from a to b of the function with respect to x variable. So this is the first property. The next we have, suppose we need to calculate the probability at a point. Let's suppose I am taking a single point here as a c. तो इस पॉइंट पे मुझे probability calculate करनी है. We will take the integration of the function from c to c because मुझे सिर्फ एक ही पॉइंट पे कैलकुलेट करनी है and it starts from c and ends at the c. This is equal to 0. It means अगर आप probability कैलकुलेट कर रहे हो सिर्फ एक पॉइंट पे, then in that case the probability is 0. बट ये चीज हमारी डिस्क्रीट रैंडम वेरिएबल में नहीं होती. फॉर द डिस्क्रीट रैंडम वेरिएबल, probability at point C is not is equal to 0 in general if that event C is happening. So in short, we can say that in a continuous random variable, probability at a point are 0. So whether the interval includes endpoint, it does not affect the probability. Means if I write probability from A to B where A is included, this is equal to the probability if I include both the points, or I can include only B point, or I am not including both the points. तो यहाँ पे probability calculate होगी, that is integration from A to B of the function with respect to x. On the other hand, we have cumulative distribution function that is called as the c.d.f. So here x is the continuous random variable with the p.d.f f of x. ये हमें probability density function given है. Then the function c.d.f is calculated by the capital of F. Here x represents the random variable and this is the random variable values. It means probability when the random variable values are less than is equal to x. Now how we can calculate this? Less than is equal to x. ये तो पता है कि एक एंड पॉइंट x है, लेकिन स्टार्टिंग पॉइंट क्या है? इन जनरल हमारा इंटरवल कहाँ से कहाँ तक होता है? माइनस इन्फिनिटी टू इन्फिनिटी. बट यहाँ पे हमें राइट एंड पॉइंट गिवन है, दैट इज द x. So instead of writing this, we say minus infinity to x. So we will take the integration from minus infinity to x of the function. अब function x की फॉर्म में था, बट हमारी लिमिट x की फॉर्म में है. That's why we replace the function with respect to the variable t. जो भी आपके पास फंक्शन होगा, write in a t form, then take its integration from minus infinity to x. This gives you the cumulative distribution function corresponding to the value x. But discrete में हम क्या करते थे? Rather than taking a integration, हम summations लेते थे all the probabilities less than is equal to x. Now we have a certain properties of cumulative distribution function. The first property is the c.d.f lies between 0 to 1. बिकॉज हमारी फंक्शन की वैल्यू ग्रेटर देन इक्वल टू 0 है, बिकॉज इट इज अ पीडीएफ. 0 की इंटीग्रेशन क्या है? ये दैट इज 0, कैन नेवर बी अ नेगेटिव. तो इट मींस f ऑफ x इज ग्रेटर देन इक्वल टू 0. मैक्सिमम प्रोबेबिलिटी कितनी हो सकती है? दैट इज अ 1. दैट्स व्हाई cdf is less than is equal to 1 for every value of x from minus infinity to infinity. Secondly, यहाँ पे हम CDF कैलकुलेट कर रहे हैं विद द हेल्प ऑफ PDF, जस्ट टेकिंग द इंटीग्रेशन ऑफ दिस. तो अगर मुझे रिवर्स रिलेशन चाहिए, आई नीड टू कैलकुलेट PDF विद द हेल्प ऑफ CDF. सो वी टेक दिस इंटीग्रेशन ओवर हियर. एंटी इंटीग्रेशन लोगे, दैट इज गोइंग टू कन्वर्ट एज अ डिफरेंशिएशन. इट मीन्स अगर मैं क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन का डेरिवेटिव लूं, this will gives you p.d.f, that is a probability density function. अब हमें ये भी पता है कि f(x) क्या है? हमेशा ग्रेटर देन इक्वल टू 0. अगर डेरिवेटिव ग्रेटर देन इक्वल टू 0 है, इट मीन्स जो ये फंक्शन है दैट इज ऑलवेज नॉन डिक्रीजिंग फंक्शन. So this is the second property. The third property is CDF at minus infinity is 0 and CDF at infinity is 1. Now how we are getting this one? So if I write f of x, it means probability when x is less than equal to x, or we can say that integration from minus infinity to x of f of x. Now what is the value of x here? That is a minus infinity. If I write f of minus infinity, it means I am taking the integration from minus infinity to minus infinity f of x dx. So हम इंटीग्रेशन ले रहे हैं सिर्फ एक पॉइंट पे. एक पॉइंट पे इंटीग्रेशन क्या आएगी? दैट इज इज इक्वल टू 0. देयरफॉर दिस इज इक्वल टू 0. Now if I write f of infinity, it means minus infinity to infinity fx dx. It means हम ये total probability ले रहे हैं on the given interval. So total probability कितनी होती है? 1. Therefore capital F, that is a c.d.f at infinity, is equal to 1. The next result is basically a relationship between a p.d.f and c.d.f. अगर आपको probability calculate करनी है between a two points A and B, it means we are taking the integration from A to B f of x dx. इसको मुझे कैपिटल f(x) की फॉर्म में लिखना है. कैसे लिखेंगे? सपोज हमारे पास एक रियल लाइन है that is minus infinity to infinity. This point is A and this point is B. So हम इंटीग्रेशन निकाल रहे हैं फंक्शन की over this interval A to B. Now I need to relate this with minus infinity so that कि मैं एक CDF फॉर्म क्रिएट कर सकूं. So अगर मैं पहले इंटीग्रेशन कैलकुलेट करूं इस रेंज की, that is minus infinity to B, then I can subtract the integration from minus infinity to A. Then I will get the integration over the interval A to B. Basically मुझे ये पिंक कलर एरिया निकालना है, तो मैं पहले टोटल एरिया निकाल लेती हूँ येलो कलर का. Then I can subtract this blue color area. Then you will get the area under the curve from A to B. So इस केस को हम लिख सकते हैं minus infinity to B f of x dx, because integration from minus infinity to B. Then I will take the integration from minus infinity to A and I will subtract that from here. Now according to this, this is equal to the probability capital X is less than equal to B, and here X is less than is equal to A. What is this? This is the cumulative distribution function at the point B. So we can write it as a f of B, and this is the cumulative function at point A, f of A. So in short, if I need to write probability of the random variable between A to B, that can be calculated with the help of cumulative, that is f of B minus f of A, where x is continuous random variable. First question is, show that a function fx given by this is a probability density function for a suitable values of a constant k. Also calculate the probability that the random variable lies between 1/2 and 3/2. अभी यहाँ पे हमें पीस वाइज डिफाइंड फंक्शन गिवन है. सपोज अगर हमारे पास रेंडम वेरिएबल है दैट लाइज बिटवीन माइनस इन्फिनिटी टू इन्फिनिटी, तो ये फंक्शन कैसे डिफाइंड है? फ्रॉम 0 to 1 द फंक्शन वैल्यू इज x. तो लेट्स सपोज हियर वी हैव 0 एंड हियर वी हैव 1. सो ओवर दिस रेंज फंक्शन की वैल्यू क्या है? दैट इज x. Then next is given as 1 to 2 function value is k minus x. So 1 से लेके 2 तक function की value क्या है? That is k minus x. Elsewhere 0. It means जो बाकी range है वहाँ पे function की value 0 है. So here the function value is 0. Here the function value is 0. According to this question, this function is probability density function for the suitable values of the constant k. तो यहाँ पे हमारे पास एक constant है k. हमें ये prove करना है ये probability density function है for some k. Basically हमें k ही निकालना है under the condition that this is a probability density function. A probability density function में दो conditions थी. पहली condition, function is greater than equal to 0 for every value of x. अब x in general we take from minus infinity to infinity. Second condition is integration from minus infinity to infinity of the function is equal to 1. So let's apply this condition second to get the value of k, for which it is a probability density function. So from here what we can write, इंटीग्रेशन इज फ्रॉम माइनस इन्फिनिटी टू इन्फिनिटी, लेकिन फंक्शन हमें पीस वाइज डिफाइन है, सो वी विल स्प्लिट दिस इंटीग्रेशन अकॉर्डिंग टू दिस इंटरवल्स, दैट इज फ्रॉम माइनस इन्फिनिटी टू 0 एफ एक्स डी एक्स, यहाँ पे फंक्शन की वैल्यू 0 है, प्लस 0 to 1 इंटीग्रेशन ऑफ द फंक्शन विद रिस्पेक्ट टू एक्स, प्लस 1 to 2 integration of function with respect to x, then 2 to infinity integration of the function with respect to x. Now here the function value is 0, even here the function value is 0, so integration of 0 is 0, even here the integration is 0. This is equal to integration from 0 to 1. इस केस में फंक्शन की वैल्यू क्या है, दैट इज x प्लस 1 to 2 function value is k minus x dx, and we need to substitute this is equal to 1. This implies integration of x is x square by 2 and limits are 0 to 1, plus here integration of k is into x because it is a constant and constant integration is x. Integration of x is x square by 2 and the limit in this case is 1 by 2. This is equal to 1. From here what we have, 1 by 2 minus lower limit that is 0 plus upper limit that gives us 2k minus 2 at lower limit minus k minus 1 by 2, that is equal to 1. Now simplify this. This is equal to 1 by 2 plus 2k minus 2 minus k plus 1 by 2 is equal to 1. This value is equal to what? This is equal to k minus 1 is equal to 1. This implies the value of k is equal to 2. It means this is the probability density function for the value of k is equal to 2. Now let's answer the second part. According to the second part, calculate the probability that the random variable lies between half to 3 by 2. It means we need to calculate the probability when x lies between 1 by 2 to 3 by 2. So we have already done either include 1 by 2 or exclude 1 by 2. The probability is same in case of continuous random variable. So how to calculate this one? This is calculated as integration from half to 3 by 2 of the function with respect to x. अब 1 by 2 किस इंटरवल में लाई कर रहा है, that is here 0 to 1.5, and 3 by 2 that is 1.5 that lies between 1 to 2. So again ये integration divide होगी into two parts, that is from half to 1 because the function between half to 1 and from 1 to 1.5 is different, plus integration from 1 to 3 by 2. In this case the function value is x and in this case the function value is k minus x. This is equal to integration of x is x square by 2. Here k into x minus x square by 2. Here the limits are 1 by 2 to 1 and here the limits are 1, 2, 3 by 2. So this is equal to upper limit 1 by 2 minus, when you substitute lower limit, half square is 1 by 4. It is again multiplied with 2, that is 1 by 8 plus. Now substitute upper limit here. This gives us 3 by 2 into k minus 3 by 2 square, that is a 9 by 4 divided by 2, that becomes 9 by 8 minus lower limit k into 1 minus 1 by 2. This is equal to 1 by 2 minus 1 by 8 plus 3 by 2, and the value of k is 2, so we can simply write here as a 3 minus 9 by 8 minus negative negative positive half. Simplify this. This is equal to 3 by 4. So this is the probability of the random variable when it lies between half to 3 by 2. Next question is, verify that the following is a distribution function. Distribution function क्या होता है? In general, it is a c.d.f. That is a cumulative distribution function. Even you can check it. This is a c.d.f. because it is given in form of capital F. So this is a c.d.f. of the random variable x, where x is a continuous random variable. तो हमें चेक करना है ये क्या वाकई c.d.f. है. अब तक हमने कोई भी कंडीशन नहीं पढ़ी जहां पे हम चेक कर सके कि गिवन फंक्शन c.d.f. है, लेकिन हम फिर भी क्रॉस वेरीफाई कर सकते हैं बट विद द हेल्प ऑफ p.d.f. अगर मुझे यहाँ से प्रोबेबिलिटी डेंसिटी फंक्शन मिल जाए, देन आई कैन चेक इट वेदर दिस इज अ डिस्ट्रीब्यूशन फंक्शन और नॉट. कैसे? We will check that whether this probability distribution function is a probability density function, means क्या यह फंक्शन की वैल्यूज greater than equal to 0 है for every value of x. Second condition is integration from minus infinity to infinity f of x is equal to 1. तो अगर हम ये दो कंडीशंस चेक कर लें तो जो भी हमारे पास फंक्शन ऑब्टेन्ड होगा फ्रॉम हेयर, दैट इज अ प्रोबेबिलिटी डेंसिटी फंक्शन. अगर वो प्रोबेबिलिटी डेंसिटी फंक्शन है, डेफिनेटली दिस इज अ c.d.f. of the random variable x. So first step in this case is calculate p.d.f. अब p.d.f. कैसे कैलकुलेट करते हैं? If we take the derivative of the c.d.f, then you will get the p.d.f. function. So here function जो है आपका piecewise defined है, means when x less than minus a the function is 0, when x lies between minus a to a the function is this, when x is greater than a the function is this. तो हमें हर एक फंक्शन का डेरिवेटिव लेना है विद रिस्पेक्ट टू x. टेक द डेरिवेटिव ऑफ द क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन विद रिस्पेक्ट टू x. दिस विल गिव यू द probability distribution function, that is equal to when x is less than minus a, derivative of 0 is 0. When x lies between minus a to a, what is the derivative of this term? 1 by 2 as it is. X derivative is 1 by a and the derivative of 1 is 0. And when x is greater than a, the function is 1 and its derivative is 0. So indirectly हमें एक नॉन जीरो फंक्शन मिल रहा है फ्रॉम माइनस ए टू ए, अदरवाइज जीरो. सो आई कैन रीराइट दिस. द फंक्शन इज 1 by 2a when x lies between minus a to a, otherwise 0. Now check it whether this satisfies these two conditions. It means the functional value is greater than equal to 0. So this implies this function must be greater than equal to 0. And second condition is integration from minus infinity to infinity of the function is equal to 1. अब फंक्शन इंटरवल्स में ब्रेक डाउन हो रहा है. In general, we are taking the values of x's from minus infinity to infinity. And let's suppose this is minus a and this point is a. From minus infinity to minus a, the function value is 0. From minus a to a, the function value is 1 by 2a. From a to infinity, the function is again 0. This means this integration is divided into three parts. Minus infinity to minus a, the function is 0, plus minus a to a, the function is 1 by 2a, plus from a to infinity, function is 0. Integration of 0 is 0. So this number is 0. And again we are getting here as a 0. Now what is the integration of 1 by 2a? 1 by 2 is a constant and constant integration is a constant into x. So here we can write 1 by 2 into a into x. And the limit of x is minus a to a. So we write 1 by 2a, upper limit a minus lower limit minus a. This is 1 by 2a, that is equal to 2 of a. This is equal to 1. So as the integration from minus infinity to infinity, it is a 1. So this implies fx is probability density function. This implies the given f of x is c.d.f of random variable x, or we can say that distribution function of the random variable x. And that's the proof of this one.